Okay, we want to talk about two things. One is reflecting through a point, which is pretty straightforward, and the other is a size transformation we'll talk about in a minute. We'll start with reflection through a point. Here I have a triangle, here I have a point. To reflect through a point, you just take every point, every vertex on the triangle, and reflect it through the point. Now, I should make that a dotted line. So we draw the line from this point through this point, and we just continue it on for ways, and then we go an equal distance on the other side of the point. We take this distance and we go to this distance, and we have our reflected point. So if this is point A, this point will be A prime. I'm not going to label that yet. I'm going to get everything done and then label the resulting point. Well, actually, I can. Okay, there's A prime. Okay, now I reflect this point. Let's call this point B and this point C. So reflecting B through the point, I just draw a dotted line and take this distance, equal distance on the other side, and that gives me a point B prime here. This is actually simpler than what we did in reflecting through a line because I never have to worry about a right angle. We just go straight through the point, and let's call this point P. Okay, then the point C, again, we see if we get that head a little better. Okay, now we go an equal distance on the other side. Let's see, that distance is here. This distance would be here. So here we would have our point C prime, and when we connect these 3 points, we see that we've got this triangle reflected through this point. The result is triangle ABC reflected through the point P. And of course, that's not constructed as well as it might have been. Lines aren't as straight as they ought to be. Distances aren't measured all that carefully. But this triangle should be geometrically similar to this one. And I can see that it is. That this side is longer than this one, although these other two sides look about right. Okay, well, done carefully, it works out. Now we talk about a size transformation. Again, we've got a triangle here, and we could label the sides A, B, C. And this time we simply draw a straight line, a dotted line, from this point through each of the vertices of the triangle. Okay. Okay, that's a fairly simple construction. Now, if we want to draw an enlarged version of this triangle, all we have to do is take this distance. Let's say we want the triangle to have sides 3 times as long as the sides of the original triangle. So we take this distance here, and we go that far, and then that far again. And now we're at a point 3 times as far from this point along this line, and we call that point A prime. We do the same with the point B. Here's our distance from the point, well, let's call this point P. Okay, from point P to point B is this far. We go that far, and that far again puts us down about here. And then this distance to point C, again and again, puts us about here. So we got points A prime, B prime, and C prime. We connect them, and we've got an enlarged version of this triangle. We could also do a smaller version. That triangle's pretty small to start with, but we can do a smaller version. We just take this distance and cut it in half. Take this distance and cut it in half. Take this distance and cut it in half, and connect the points. And I didn't do a real good job of that, but estimating the half from this angle is a little difficult. But if you do that correctly and carefully, then you could have a triangle A double prime, B double prime, C double prime at half the scale. And my point B double prime, I can't tell really. That point's probably a little too far. If it moves up a little bit, I think we get a better indication of the shape. These triangles will all be geometrically similar. So we have geometrically similar triangles of different sizes. Now, in your text, you'll read more about all these transformations. But if you understand these principles of construction, everything should make pretty good sense to you. And, of course, we'll pick up this discussion again next week.